Hello everyone, welcome back to Calculus 3 again. We are still in section 2.2, vectors in three-dimensional space. And I think one quick thing I want to remind, when you draw the three-dimensional space on a piece of paper on a plane, make sure you are aware of the right-hand rule. Or put it in a simple way, you can consider x, y, z must be arranged in the counterclockwise direction, like shown here, okay? And also, just to help better understand the three-dimensional space, I'm going to take a quick look at this example, example 2.16, graphing other equations in the three-dimensional space. Describe the set of points that satisfy this equation. I say this may look very simple, right? This is really indeed will generate two equations because we are having a product equal to 0. So we can set each product equal to 0, and then what we are really having here is x equals 4, z equals 2. And normally we say x equals 4, that's a single value or single point. Z equals 2, that is a single value. But anyway, you want to understand that we are talking about three-dimensional space. So it's a little more complicated. X equals 4. X equals 4. It is the orange color. Well, how do you call this? I say that's kind of a little bit like a brownish or orange colored plane, vertical plane. It is 4 units in the front of YZ plane. That is the actual meaning of x equals 4. It's not just a single value. Then accordingly, z equals 2, it is not a single value. It is the, I don't know the color here, the bluish or thin color. Yeah, the plane, the horizontal plane, which is 2 units above the xy plane. Or simply put, I mean x equals 4, z equals 2, that is the plane. And also it's worth to mention, in general, any equation you see in the three-dimensional space, mostly it will be a surface. Certainly a plane is considered a surface too. Okay. So very basic understanding the three-dimensional space. Any questions? Okay, I'm going to move on. Okay, it's a discussion of vectors. Hopefully, you know, if you read my notes, you know, vectors in the three-dimensional space basically can be represented as an ordered triple. And well, when we have a point, it's an ordered triple, and then we have vector as an ordered triple. And for now, let's just follow the rule on the textbook. When we meant vectors, we use angle brackets. When we mean points, we use those round parentheses. Okay, so this is a vector, this is a vector. And then let's take a look at how the vector would look like. This vector, when we are having ordered triple, like in the two-dimensional case, ordered pair to denote a vector, we assume a vector started from the origin and then pointing at a particular point. So indeed, this kind of orange-colored line segment with an arrow with direction, that is the vector I'm talking about. V2, 4, 1, that is the vector, okay. And also another small thing was to mention, we are having vectors V in the bold print if you read the textbook. And the bold print from now on, mostly that's for vectors. Even that is 0, it is a vector. And then x, y, z in the regular fashion. Indeed, these are supposed to be some real numbers. And indeed, to make a difference, we don't want to mess up with vectors. We say these are scalars. And put in a simple way, scalars are real numbers. Scalars are real numbers. Some single real numbers. And the vectors could be ordered pair or ordered triple in the two-dimensional case, in the three-dimensional case. Okay. And then, like what we discussed in the previous section for vectors, two-dimensional vectors, three-dimensional vectors, indeed we still have the scalar multiplication and vector addition. I really don't want to repeat a whole lot. Pretty much they follow the same way like we did for the two-dimensional vectors. When you add vectors, you're adding the corresponding components together. When you're doing with the scalar multiplication, you multiply the scalar quantity to each component of the vector. And also, there's some geometric interpretation. When you multiply vector by -1, it is generating a vector of the same length, but pointing to the opposite direction. And indeed, we do write -1 times v as -v, which means opposite of the v. Okay, and also using the scalar multiplication, now we can say the subtraction, it is the addition by the opposite. Addition by the opposite. Subtraction. Any questions here? And vector with the initial point, terminal point, and well, now we are having two ordered triples. And how do we know the vector? Well, the vector from point P to point Q basically should be considered as an ordered triple such that the corresponding component of Q minus the corresponding component of P. Or put it in a simple way, can I say it's Q minus P? So specifically, the vector pointing from P to Q, well, this is the vector from point P to Q, -7, -15, -4. Not a single ordered triple. It is a combination, or really it is a difference of those two ordered triples and for the vector. And also another small thing to remind, do you know what are I, J, and K? I, J, K, those are unit vectors. I, it is the unit vector in the direction of x. J is the unit vector in the direction of y. K, it is the unit vector in the direction of z. Okay, I, J, K are unit vectors. And a unit vector, it is a vector with magnitude 1. So we use I, J, K a lot. Keep in mind that those two forms are equivalent. We call this as the component form, and this is the representation using unit vectors. They are the same. Okay. And also, when you have angle brackets, you really don't need to use I, J, K anymore. If you are using I, J, K, then don't use angle brackets. Two-dimensional vectors, three-dimensional vectors, and pretty much they are about the same thing. They are about same thing. And the vector magnitude, it is the square root of the sum of squares of each component. That's the vector magnitude. And this part might be a little confusing. Okay. On the textbook, it is using the double bars to denote a norm. In writing, practically, we just simply use the absolute value notation to denote the norm. Okay, that's the norm or the magnitude. Okay, then the unit vector in the direction of v simply can be found by multiplying the reciprocal of the magnitude of the vector to vector itself. That will always give a unit vector in the same direction. Anything we can take a quick look? I don't know. Maybe can we just give a try this example? Let's take a quick look here. V, it is given such, W, it is given such, and then the textbook, it is having a drawing here, V and the W roughly in those cases. And then 3V minus 2W, I suppose you understand that this is a combination of the so-called scalar multiplication and addition, vector addition. So first, the vector V, each component of vector V, it is multiplied by 3. And then each component W, it is multiplied by -2. Then you add the corresponding components together. 3V minus 2W. And this one, I guess, for part B and part C, you may wonder why the textbook kind of showing two different ways. Indeed, they are the same thing. They are the same thing. Okay. So this part, it means that we are finding the norm of W, and then, or the magnitude of W, then multiply the magnitude by 5. And the part C, it has different meaning. We are multiplying the vector by 5 first, and then we want to find out this magnitude. Okay, so in this case, what we can do here is that, well, you can tell this is 3V minus 2W. This is how we get it. This is what we got it here. And the part B, you see the textbook follows the rules strictly. It is 5 times square root of 2. But anyway, if you multiply this 5 to the vector, then you find out the magnitude, it turns out to be the same because they are just the same. And then the part D, it is to find out a unit vector in the same direction of V. I hope you feel comfortable to read this notation. This simply means the vector V, it is multiplied by the reciprocal of the magnitude. This is the magnitude. This is the reciprocal of the magnitude multiplied to the vector itself. So we are having a vector like such. I say that is pretty much all I have for section 2.2. And also I have a summary of two sections, 2.1 and 2.2 for both sections. And so if you needed it, you also can read my notes and watch that part of the video too. And again, thank you for watching. See you next time.